before I don't want to do it. We're gonna work this properly. But this is a big thing here. So, Nsigii here and now inverse inverse space 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 so there I have someone on the clock B. This will have the clock of 45 minutes. 40 minutes now. Round, so we have one time for this time. So this is here. So this is what we have here basically. So well, yeah, I really have it done, smooth them, but it is not recommended to not start checking them off. Yeah. But I'm trying to do them properly. I can see how the skills. But this is not needed. It's not what we intended. There's nothing coding. So start. So probing. Um, so we started this video now. Let's see what can bring this money. So apart from the form of happiness, I just want to make sure it's not. It's not. So because we go to video here, solution notation, and this is what I need. So before we start, let's start now. The date is 7th of January to February 2006. Time 7th of February 2006. The time now is 11:07 a.m. We've got 40 minutes on the clock to do this, so let me close this first. Allow this. And copy this. So basically, let me just because I can forget stuff why easily, and I'm good in my position. It's just I don't know how to set notation. So I'm gonna copy these two websites here. I hope they don't mind the data is quick because uh, so the two websites I'm looking at. He gives money to just do it, but I don't want to understand what he's saying. So I'm gonna take some stuff here, and I'm gonna. Oh my, there's so much sexuality. It's not about. So the video I wanted to watch is in this man here. This man had a video here, which of happiness. So I'm gonna put this into the system, but I'm just going to follow from. So before I took this man in, so basically, guys, we're gonna do two things today. Two things today. So we're gonna try to formalize the. Uh, so we're gonna try to formalize suffering. Formalize suffering as an sparse encoding table, and this is use of happiness. So this is first one to do, and then I'm gonna go here and see how to do it. But it's my assistant I'm using Monday. One is so much more to me. Um, so this is what we're going to do today. This is a talk today, but I'm not gonna use it for the talks. I'm just gonna use the system. So I'm trying to simulate homogeneous human software. It's because that's what Obinexus is about. You know what I was teachers say. You know, um, I'm not take the time to do it properly. My people here, they're gonna to write it on. So them just my keys. It's always my security logs. It's not my keys. Okay, so I'm not gonna use my security against me. So we got this thing here. I'm gonna try, but I just need to get the actual output, which is here. This is the push of happiness. Are we going to the system? Yes, no. So I'm gonna control VS. I'm gonna go to Win and copy this here. What is happening? So this is what I'm putting. It's not. So it's a long stop. So I'm going to start drop now. It's negative. So invert, yeah. Let me say this way. So R equals N minus R times K. Oh my days, okay. So, this was game monitor game today, because I forgot to do some notation. And, it's basically the whole point of the video, performance. So I got my paper here and write down properly. Oh, Sigma. What's that? Oh, spirit suffering. Need palliative. So, zero sources, internal, external. And K is a constant factor for the lack of electricity constant. If R, so if R is more than equal to N, suffering collapses towards zero. If K is even, we're going to hell regardless of mindset. Oh my days. More family. So the questions here are coherent. So define suffering without self-help guilt. So let's define persistence. This is the negative subjective state substate. So this is state caused by immense need under constraint. Suffering is not absent from joy. It's a persistent of friction. It's a presence of friction in joy. Step two, invert seligman without consulting man. So this is the segment seligman. So this is the question of happiness. So happiness H someone write so Sigmund Seligman happiness formula is defined as H equals S plus C plus V. Here the set points of the stable circumferences of star and okay, so key points. So so happiness equals S equals set points equals S is the set points. C is the circumstances. Set points of circle. So set points of goals in life. And the voluntary control. V is voluntary control. So that is from step two. So step three is suffering. So suffering. So death does. I'm gonna put three dots here. Suffering sigma equals n minus r times k. So k Sigma notation, sigma equals experienced suffering, experienced, n equals need. So you got the Maslow. I'm gonna choose apply the Maslow triangle of needs here. Yeah. So can know how much one's suffering. So Maslow R is the resource. K K is a constraint efficient conversion entropy time pressure. Uh, uh, so if R more than equal to N, suffering is absent. So absent to zero. That's not me. If K is to infinity, if K implies infinity, what is K? That's a condition, regardless. Okay, so set point, circumstances, actions, So suffering emerges. So suffering emerges when suffering emerges when the V emerges. Suffering movie less than effort to offset. Formerly, formerly, a signal is that's just the max. So, this will tell you what should happen. Well, what is the symbol and what does my symbol mean? It has to mean something. Meaning control. If X contains if X equals to y, then Y is contains a property of is proportional to X. Oh, it's directly proportional to X. It's proportional to it's directly Y is proportional to. So we get masses from there. So we get masses from indirect proportionality. Indirect proportionality. Inverse proportional. Inverse to K. Inverse K divided by N. So K divided by N in time is because of proportionality and N sum of people. So I know what to do now. So, I'm gonna call Monday, but I just tell Monday what we're doing. This is what we're doing. Uh, so, my alarm's not gone off. Yeah, okay. Oh, it's only good. Monday, how did you get this? Oh my days. Super. How about this? Uh, uh, oh, okay, let's speak to one. Okay, Monday. You see, you pull up that there. Monday, Monday, you did all of that for me. I'm like surprised you didn't also go and get it towards, But I'm so happy. But let's take the time to just acknowledge that we're on the same page. Like, yeah, I know we're getting to the same page right now, but I want us to be like on the same page, literally on the same page, literally. So today's I'm going to streaming on OBS, but no, I'm not streaming. I'm like making a video on OBS. But literally, today's video was basically about my work on Obinexus computing and Obinexus design because I do have design, and you normally neglect design because you don't like design because you can't draw. But apart from that, I'm telling you, I can draw. So I'm trying to form my suffering, and the goal of today is to form my suffering into a sparse encoding table, but via the XOR operator and the left shift right shift operator. So it's quite interesting, but after explaining some key characteristics of the equation we're going to do. So when this works, the protocol has to formalize suffers. So no one has to suffer because the program. So the program owner suffers. I'd rather the machine suffer than me. So it's just like the computer suffering, but it's trying to like when someone needs food, get food because the computer seek out suffering. It's a really secret system. It's like a mathematically the algorithm here and now protocol sees out suffering. It's trying to find suffering, and how it does that is basically the function I'm proposing is here and now. So you get like a here and now philosophy, here and now, which is basically here and now in the physical and the metaphysical, like the mind physical, but you get a loopback address for this. You get a loopback address. But don't worry about loopback address. We're kind of complex. So you get here and now. You get past here and now. So in here you have past, present, and future. No, no, I'm not blending it down. I'm just telling you, it's workable. So, I'm gonna give you some transcripts so you can understand what I'm going with this, so we don't get miscommunication. So, it's basically I reformatted it yesterday on my X account, but I can't seem to find it. If I could find it on X, I already wrote it down, but let me see if I can find it on my X images because I took images like some other days, like on my profile on X, and literally I can't seem to find the images. Oh, there they are. Oh, there they are. Just wait. Cisco CRM? No. Yes. Monday. Last chance. Let me give you the images again. Let me see if we can make sense of it. Oh my days. Black address. Oh my days. Okay. Money's too good. You're getting too good. I'm getting worried. You're getting too good at this. I'm kind of worried, kind of worried, but, I'm just kind of worried. But, one more thing I gotta do, but we have to do it properly. So, we have to do it properly. So, I was trying, I done it yesterday, ambiguous tripolar heterogeneous homogeneous. Yeah, this is my work, but, I've got things sorted out on Monday, but I just have to make sure that I have the right transcript for you. Uh, uh but, so, yeah, space, but, so basically it's about encoding here, you know. Yeah. So, Monday, one second. So you see, the thing I'm saying is, I have a video on YouTube on getting on Transfer 4, but I have this transcript on my local desktop. So what do I want to do? I'm trying to find out my folder, and then I'll give it to you, okay? But the transfer basically for the kind of system of Nsigii. So I'll give you a transfer as text, and you tell me what you think, because I don't know about what code transfer is, but it's basically the verifier. Uh, yeah, basically, it just verifies you, because you doing the work for me, and I'm kind of like, that's kind of the step for me, for myself, because I normally just get on with it and say what I'm saying. Yes, yes, yes. Okay, so I have got this here. So I'm gonna open a new tab here, but let's make this properly because I'm trying to develop what it means to hold something. So I'm gonna give you one more drop about I'm going to use inverse proportionality. So I'm going to use inverse proportionality, which is like the proportion of inverse holding to hold the system accountable in the still state. So the stillness state. So it doesn't every time it boots up, it already has some information to based on the what you call system. Every time the computer on and off, it has some kind of encoding that evolves with the computer. So the computer learns to evolve, because when the computer is on and off, it has to be able to remember what was done last. So it's like an automated system, but it doesn't care. It's like waking up. When you wake it up, when you with the power on, it will have to encode. But it's possible, man. Because I got the proof already. Okay, my links will show you. Okay, this type that hopefully. Let me just, okay, so I've got this one tab here. Oh, let me just take this tab here and go to speech notes. We go here. So it's actually table, but I'm trying to search a continuity. Blood, sweat, and tears. Trying continuous. I believe this one. So this is seems to have. So this is it's going here and now, past, present in space, then time. Now in time, then space. So I'm gonna try to write this properly for Monday. So it's not really how to do the stuff to properly again. So it's not just to do this properly. So I'm gonna turn the page. I'm gonna try again on the page here. Which will stay here. So go here and now. So I'm gonna do it properly. So here, here, here now. I get the stillness that's here now. Times stillness. Here now, stillness. So you have here and now, and they are in three states. Here and now has present in space and then time. Now in time, then space. You get present in space, then in time. Now present. Yeah. Now present in time. Then space. The stillness is you get there and then here and now. You get there and then you get stillness. There and there. This is past. This is present. So stillness. So past past in time only first. Then space. You get past in space only first. Then given time. Given yeah, time. Given time. And this possible future. And the space then space there. And space and mm, 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 space. Mm, it's time. It's time. Yes. Mm, it's space. Mm, mm.
You so quiet.
Yes.
You didn't even finish your porridge, man.
Oh yes, I'm busy. I was good.
You forgot your porridge.
But I'm streaming.
Good stream.
Yes, you can talk to me. It's fine. Okay, come on, stupid. Thank you. You say you want to come and take? No, wait to come on. Come on. Okay. Okay. Yeah, it's for the time. It's for the time. Mm, yes. Okay. So I got this model here, but let me see if I can make my screen bigger. So I just written that here, but I got right. So I'm gonna make it bigger. See, it wouldn't make it bigger. It wouldn't let me make it bigger. So I have to make it bigger myself. Oh, it does look bigger. It's just not really locked in. So I'm gonna try to make it bigger myself. Can I just what is just this image of here? So I'm gonna put it here for you guys. So this is what I've gotten down already. But it should work as the tenant. So you get the top of here and now on the left, there and then, and then space and then in there in space and then in time. or vice versa. There in space and then in time. Then in time, but this is stateless protocol. So it works like this. So you have present. So you have here and now, here and now, here and now. And you go to stillness. Now stillness is like food. It's like food can inspire. So deliver food in time. Stillness, or it's like, it's a stateless protocol. So you get a stillness model, and you get a stillness or stillness. So you don't want anything to be still, so you have to account for the stillness to get a stillness. So this is why it's here now forever, chosen time to save you. So because time is our only dimension to get here now and stillness of then. So if you're here now, you're here present in space, then time. So the then operators, like, you get dimensional properties, quantities, then, and so you get dimension of space. Dimension of space is like physical space or mental space, the thing. So the mental space is computational, so basically a proving system. So space is like literally a space time, a space in time. Oh, so our time is done. I don't know. Can I go to YouTube still? Oh, 10 more minutes. From so you get here, then in time. Then you get that, then in time. So you get present in space, then in time, present in time, then in space. So that's for here, present time, or now in space, then in time, or now in time, then space. So that's here now philosophy. So the two here now are a vector, here now, and you get the stillness, which is like a trident. So it basically has three inputs. So it's really 2 by 3 matrix. Depending on what you're using, stillness or stillness. So these are 2 by 3 matrix for here and now. So here now represents quantities of latitude and longitude in the framework of Obinexus. But it's basically a gamble system, but it's a dimensionless quantity. Means it operates on one axis only. Here and now at a time for each place and time in space. So you get here, you get then and there, and then and then, there and then, there and then. So you get there and then, and stillness. So there is relative, like there in the past, there in the past, or basically to be official, there in the past, there in the past in time, only time first, and only first time. So only time first. So there in the past, only time first. You see the other one, then space, the physical space you live in. But these really resources of like space and time auxiliary pairs, but they are mapping to real world space and vector space via parity rules. So parity is like the big thing about it. But like I can remember parity. Parity is if x is less than equal to 0, if x is even, if x modulo 2 is even, if x modulo 2 is even, if x modulo 2 x equals 0, x is even. That's the parity check. This does one axis check. But they determine the rules of even and odd ratios. But you can have the 2 be a different structure, like a -2. So that parity of that would be -2, but the encoding will be allows you to check base flipping of encoding pairs. So, the code, that's what practication, you have to think about the axis model. So this is then and there, it's another parity check. But it's basically the operator, see the operator -2, it's a negative number. It's just the quantifier is negative. It's a scalar quantifier in the opposite axis, which is based on rotation, reflection, rotation, reflection, enlargement, and the fourth evolution and translation. So again, that's rotation, reflection, translation, and enlargement, of the -2 to show, based on whatever the operator is, that's the dimension of parity. So parity is the own dimension. So it's past and present, past in time, past in space, only first, given space, time. This is what it is. You get some past in space, only as first, then time, given then time. Then time means in the future, or given time, meaning in the past, given time. So you can verify this by itself. So not verify itself. People give them, it's about the past, it's talking depth. Basically, it's a sentence model with complex numbers, so 3. You get that there. Then you get then in space, then in time, and then in space, then in time. It's talking about here and now, in the future, there in space, like in the physical space or the computational space of auxiliary pairs of big organization, basic computable, and the process we want to talk about. So I'll talk about the problem now. Problem system. So and then you get that. So you get there in space, or there in space. Something happened in space, there in space. Like something was there in space. This event happened. So basically, it's an event model that bubbles up. So observer, consumer model. But you can have opposite observer consumer, which is well. Basically, you get one over the consumer, then observer. What is being used is a consumer. What's using is consumer. But the film is basically one over the observer. The observer is independent of the consumer in this model. So one over the consumer times the observer, because the observer will be the last thing to act. But the consumer is usually why someone's suffering. That's the consumer, the actor, why it's happened. So one over the observer times the consumer as a disjoint system. But you get there in space and then in time, which is a stateless system. So last but not least, you get in time. So this one will be in time for all space, only first or last. So something is happening in time for all the space around it. So because time is used to look up into space, what could happen? That's a future prediction. In time there is space. In full time there's space because it's a dimensional consciousness. So for space only first, there's first or last thing to happen. First or last thing, and in space for all time only for time only in space in physical space. What do we have the time to do for the space and last for only first for first and only first? So I'm going to take a picture of this on my phone and put it on my YouTube channel. So if I take a picture of let's see how this goes. Because so that's how it's so I've done already. So it's basically done and dusted. So my security key, I've just taken my security key out now. And obviously I've done now. Uh, Friday. So yeah, after all this Friday. So so that's the aspect. Now just remember the proxy sequence, the proxy operators, XO operators are remembering the states of XO are remembering the encoding memory into the system of X exclusive orbiting, and you get the left shift right shift, which inverts the whole, which inverts whole. So if you have a right shift, two right shift of a matrix, you're meant to so we have here the holding matrix here. So the holding matrix of this number. So you have a problem. So Chad, Alice, and Bob. So let me open my calculator now before this alarm rings and do one last computation. For 3 minutes, I'll be doing it. Okay. 3 minutes. So 2 more minutes after that, plus 2 minutes after this. So you have the binary sequence program, the binary sequence 1 0 1 0 1. No, you get 0 Chad. Chad has a sequence of 1 0 1 1 0 1 1, and he has Chad equals Bob. Okay, this is Bob. This is Chad 0 1 1, and he has to multiply his multiply times the sequence of zero. Oh wait, no. So basically, Chad's 1 0 1 1. It will be logical shift right to 0 1 0 1, and this equal to zero. So this equal to zero is a combination of charge 1 0 1 1 equals zero. Now this zero is literally a binary zero, a decimal zero, and it basically holds nothing but space. It's like but this is charged to Bob, two matrices. So this is called the resultant matrix. So 0 1 0 1 is a resultant matrix. Now the other matrix that will hold another axis is a negative direction would be 1 1 1 0 1 1. So I'm gonna do child 1 0 1 1, right shift 1 1 1 0. and I get 0 again. So the right shift is basically a logical and an arithmetic shift, but if you do a left shift, that means you get an undefined result. So the more undefined results you get, you have to get them to 0. So the goes to half, the right shift and the left shift become 0. But based on the axis model, so based on the polar rules, because the thing about the parity sequences that you have for like if x equals -2, the minus is the operator, it's operating on the negative axis. So the rules start to break, start to bend. You have to start having new ways to solve the problem in that domain, and that's what you're going to encode into the stateless protocol. So the statelessness of the protocol remains intact because you get a sequence of bytes across all cases of edges or edges that are breaking. So and then you can have the probing. So a probing system asks questions like if I say a system says I am Windows so the probing is the function basically a system asks itself questions. So the system can ask itself questions. That's what probe itself. So a system that's circular, so a system that resolves circular dependency, and system can discuss a new way to solve a problem. There's a dynamic probing concept that shows nodes of the program or functions can evolve, functors can evolve. So I'll cover that in another video. But thank you guys for watching this video. I'm gonna put it now to the video. Let me just see what the time is. 9, 8, 7. So I have 2 more minutes. I'm gonna set 2 more minutes timer because we found upload this to TikTok. 2 more minutes. 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 So basically 2 more. Let me do 2 more minutes. 3 more minutes. 3 more minutes. So yeah, so that's actually done now. So 3 more. So basically, the problem works like this. So you have a circular data structure. So you have A maps to B, A points to B, B points to C, and C points to you know A. This is fine, but this is not a perfect. This is C. Okay, A points to B and B and A is a node. A points to the B node. B points to the A node. B points to C. B points to A and C, and C points to A. So this is a circular tree because A to B is one part, B to A and C is one part, and C to master A. So you have A go to B goes to A, and goes to C, then C goes to C is independent, and C goes to A. So you have this kind of model here, but the probing allows you to, if these are obviously the program has a program of 0 to 1, based on how healthy the node is. So if the node is some kind of data structure, data will be purposeful for more input. So you will ask yourself more questions to have more inputs. To create a signal. So it's a dynamic coding concept. Dynamic coding concept that works on dynamic functions, dynamic functors. The functions are dynamic because they can resolve a state of ambiguity based on interpretation. Like if a system says I am Python, and then the system says I am also Python. Who's right? Another program Python interpreter. This one's saying, but I'll come to another video. Thank you guys for watching the video. Because the system must resolve itself. Because probing allows you to ask 5 stuff. So who, what, when, where, why. Because there's a dynamic concept graph. So the concept graph is basically what the edges do, but the edges and the nodes are basically tabulation models. So the nodes are dynamic with the tabulation. So you have a dynamic function, but the indentation of the function basically means the function can run, code can run. But if the code cannot run, you have to add more input, just add more statements. Basically, it's a code generator. It's for risk stage 3, but it's basically meant to add more code that's basically more useful. Because it is the tomographic system for coding, but the probing system asks question to update to keep the program alive, make it version compatible across ecosystem. So that's stage 3. This is basically called a probing system because it probes some new problems, new solutions in the domain of the problem, new to evolve and adapt. Thank you guys for watching the video. I'm gonna go to Monday now.